Do you feel the vibes?
Okay, this is about sequences and series, right? We're gonna start in section 1 with like a general overview of sequences and series, and then in sections 2 and 3 go kind of more specific into the different types of sequences and series. A sequence is basically an ordered list of numbers, and so that's all it is. It's a list of numbers, right? Each number in a sequence is called a term. Now, a finite sequence contains a finite number of terms. So, for example, it contains 100 terms, 5 terms, 8 terms, whatever, right? So, for example, this is a finite sequence, 1, 3, 5, 7, 9, right? These are the odd numbers from 1 to 9. An infinite sequence is just that. It has an infinite number of terms. So, for example, if you have, 2, 4, 6, 8, dot, dot, dot. And so this, the ellipses, dot, dot, dot is how we denote that it's an infinite series. But right now this is going to be just all of the even numbers, period. Okay? All of the positive even numbers. All right, so let's talk a little bit about notation. The individual terms in a sequence are labeled as a sub 1, a sub 2, a sub 3, right? So for example, here, this is, the value of it is 135, but this is the first term. It will be a sub 1, a sub 2, a sub 3, and so on. Therefore, or they may start from a0, so then it would be, a sub 0, 1, 2, 3. Usually, we have, like, if you're writing a series yourself, you have, the choice, and then, but you should know that, like how something is written. You should be aware of that. So now a generic term is given the label a sub n. Okay, now, if you have a sub n, so for example, if in this initial list, if that 5 is a sub n, the one right before it is a sub n minus 1, right? So for example, if this is the third term, this is 3 minus 1, the second term. The one right after it is a sub n plus 1. All right, so that's how we label those. So for example, a list can be written like this, right? So look, in the middle it's a sub n, and then before that n minus 1, n minus 2, and after it n plus 1, n plus 2. Okay? All right, so that's just a little bit about notation. Okay, a sequence can be represented as a function in which an denotes the nth term. And you can come up with an explicit formula that gives the nth term. So for example, if you have the explicit formula, then with that, you can generate all of the numbers in your sequence. You can come up with the first, second, third, and so on. So for example, we have to find a sub 4 if a sub n has this formula. Do you see how this is a function? It's a function of n, the variable is n. The name of the function is a sub n instead of f of x, okay? So with this, you can, if you wanted, you can populate the entire sequence, the entire list. But here, all we want is a sub 4, so we say, okay, a sub 4 is 3 times, this means n equals 4 plus 1 over 2. So a sub 4 is 13 over 2. Okay, so the good thing about this is you can just jump to any sequence, any term in the sequence. So for example, if you, for some reason, you wanted to find like the 254th term, you could just do it in one shot. You don't have to like count up to it. Okay, so here, find the next 4 terms in the following sequences. Many times a sequence will have a pattern, and you can use that pattern to like extrapolate or to find the terms that come up. So the way we do this is usually the following. How do you go from first to second term? So 3 to negative 1. What are some things you could do? You could subtract 4. Okay, so now let's see, does that work here? Yeah, does that work here? Of course, it has to be consistent. So this will be negative 13, negative 17, negative 21. Okay, I know you guys know how to do that. Okay, here it looks like we add 3, but then I add 5, but then I add 7. Okay, so I'm adding consecutive odd numbers. So the next one would be 26, 37, 50, and 65. And then here, if I just have the explicit formula given and I want to find the next 4 numbers, well, we start with a sub 1. For default, let's assume it's a sub 1 and not a sub 0. So a sub 1, it's 1 cubed plus 1, which is 2. And then what would a sub 2 be? 9. A sub 3, 28. 65. Right? So it's 2, 9, 28, 65, and so on. All right? All right. So, yeah.
So for A, would like the formula, like the function, it would be an equals n minus 4.
Yeah.
And then you can't write any like function.
It wouldn't be an equals, well, we're going to do all that. Yeah. Huh?
Oh my god.
What? What? Oh my God, 1,000? Jeez, not in Precalc Honors. Oh no, not 1,000. Wow. Okay. All right. So, okay. So, what about a recursively defined sequence? So that with the explicit formula, right, you could jump, like I said, to the 254th term, okay? So you can hop from, to any term that you want. With a recursive function, these are the recursive sequences give you a few initial values, and then you have a recipe for finding the very next one. Okay, so the next one after that, and the next one after that, and the next one after that. Okay, so an example is this. A sub 1 is 1, and then A sub n is a n minus 1 plus 2. So what this is saying is, if you want to find a term, you have to use, what is this term in relation to this? The one right before, okay? So you have to use the one right before and add 2. So with this, you have the term, you can find the very next one. Then you can find the very next one. Then you can find the very next one. You can't skip from the first term to the 50th term with this. You can only go from the 49th to the 50th. This is called a recursively defined sequence. So take a look here. Find the 4th term of the recursively defined sequence. A sub 1 is this. A sub n, you have this recipe where n is greater than or equal to 2. Okay, so here, let's do this. So a sub 1 is 3. Now a sub 2 is 3 times the term before, which is 3, minus n is 2 here, plus 2. So that would be a 9. Right? Okay, so this one is the value right before this, right? And then this is just n, which is 2.
Why is it 3 times 2?
Because the formula is 3 times the value right before. Let's do the next one and you'll see, because then we won't have too many 3s. So look, a sub 3. The formula is 3 times a n minus 1. That means the value right before, which was a 9, right? Use the one before. Okay.
Wouldn't it be
The one before
3 and it's minus 1 and then it would be
No. This is a sub n minus 1. Okay. This is a sub 1. Okay, a sub 1. Now you want a sub n. You want a sub 2. This is the second term. So this is, hang on, look up here. Up here. This is 3 times, when you say a sub n minus 1, right? It's the value right before. So look, I have a list here. Okay, I have a sub 1, a sub 2, a sub 3, a sub 4. A sub 1 is 3. That's the first number. Now, a sub 2, I want to find the second number. That means it's 3 times the number right before. Okay, 3 times 3 minus 2 plus 2. Huh?
Why is it minus 2, not minus 3?
Because it's minus n. What's n for this one? 2. Okay, now look. This is a sub 3. Guys, look up here for a minute. This is a sub 3. That means here, n is equal to 3. Okay, because it's literally the third term. N is equal to 3. So the formula is 3 an minus 1, the previous term, minus n, which is 3, plus 2. So that would be 27 minus 3 plus 2 is 26. So this we got 9, this we got 26. Let's do another one. Let's do a sub 4. Right? We have to do another one anyway. So here, how much is n in this term? 4. Right? A sub 4 means n equals 4. So this is going to be, okay, hang on. 3 times, why can't I pick this other color? Okay, so look, this is going to be 3 times a sub n minus 1. That is the number right before. The number right before this was 26. Minus the value of n, right? The value of n here is 4 plus 2. So that gives you 76. Okay, so a sub 4 is 76. Okay. So the Fibonacci sequence, have you guys heard of the Fibonacci sequence? The Fibonacci sequence, basically it's a sequence of numbers that here's the formula for it. So the first number is 0. So here, the first value is 0. The second value is 1. Then every other number, so a sub n, this one, is the sum of the one right before and the one right before that, the 2 previous ones. So what would that number be? 1. And then the next one, you would add these 2, you would get 2. The next one, you would add these 2, you would get 3, and so on. And you can continue that forever. So look, each one, this is a sub n. Okay? A sub n. This is the one right before. This is the one right before that. Okay? Questions on this? Okay. So the Fibonacci sequence is actually like, this is the golden ratio. So it's found in like everything. So I don't have any pictures of that here. Adding, because look, it's a sub n plus 1 minus 1 plus a sub n minus 2. Okay? Yeah.
I have another question. So my question is, how does it get from 0 to 1 if there's a complexity?
That's just a given. You start from that. Okay? You start from, and so everything. So for example, if you look at like leaves on a tree, the first branch that you plant will have like one leaf and then or one branch, and then another one will have, the next one will have one. Then from that, each will branch up to 2. Then from that, each will branch up to 3. It's the Fibonacci sequence. And then like if you look at like, you know, like anywhere in nature, like the human body, for example, the ratio here to here to here, like it's all like the Fibonacci sequence. Okay? Yeah, it's a very, that's what's called the golden ratio. And then if you take the ratio, it's 1.718 something. Okay. So let's talk about convergent and divergent sequences. I don't want to overcomplicate things, but basically, if the terms of a sequence approach a unique number, then the sequence has a limit and is said to converge. So for example, look, the first number in this list of numbers is 0.4. The next one is 0.2, then 0.1, then I don't know, 9 or something, and so on. And then you see how they all are gradually, the numbers are approaching a value of 0. That means this converges. Take a look at this one. If the numbers do not approach a specific value, then we say the sequence diverges. So take a look at this one. Let's say it's like 0.1. Then the next one is, let's say, 2. Then the next one is 0.5. Then it's negative something. Do you see how these values are just going back and forth? They're jumping up and down, and they are not zeroing in. They are not converging on one specific number. That means that sequence diverges. So let's take a look at some examples here. We have this explicit formula of a function, of a sequence. We want to see if this converges or diverges. The way in which you want to do it, the way in which I want you to do it, is I want you to come up with the first few values and see what pattern there is. Okay. Okay, so take a look here. So we're going to do a sub 0. A sub 0 is negative 4,000. So that's just negative 4,000. Okay? Okay, yes, but now, I said generally, but now we're starting at a sub 0. For these, start at 0 because we're going to graph it now. So, okay, yes. Oh, okay. So look, a sub 1 is negative 4,000, negative 1 over 4 to the 1, which would be 1,000. A sub 2, I know you guys all know how to plug this into your calculator, so I'm going to give you guys the values here. Negative 250. A sub 3, negative 4,000, negative 1 over 4 to the power of 3, 62.5. So let's just give the other values now. A sub 4, positive. A sub 4 is negative 15. 5 is 3.9. 6 is negative 0.97. Okay. So, before you do anything, there are a couple of things. Remember, it's never about the answer, it's about the process, right? So there are a couple of things that I want you guys to be aware of here. Take a look here. This is negative, then positive, then negative, then positive. So do you see how this is alternating sign, right? So now let's go back to the formula. Let's go back to the formula. What you have here is a negative number to the power of n. We know that when you raise a negative number to an even exponent, it becomes positive. A negative number to an odd exponent becomes negative, right? So whenever you have a negative to the power of n, the values are always going to alternate. This is something in the world of sequences and series that you should just know and see a mile away. Again, billboard. If I saw this on a billboard, right, driving down whatever to Pena Canyon, the first thing I would say is the signs are going to alternate here. Positive, negative, positive, negative, positive, negative. All right? Okay. So now when you graph this, I actually didn't give you guys the space to do a sub 0, but it's okay. Let's do a sub 1. It's 1,000. And then it's negative 250. And then it's 62.5. Negative 15, 3.9, negative 0.97. Okay, do you see how, yes, it's alternating like crazy, but do you see how eventually the numbers are approaching to a specific value of 0, right? That means this sequence converges, right? So we say it's convergent. Okay. Let's do the next one. So much fun. Okay. So, a sub 1. Yeah, go. Yes, but that's not the only definition. In fact, the definition was never alternating sign. The definition was, does it approach specific value? So here, that's why I specifically choose that one. Here, it goes like up and down like this. It alternates sign, but also it's not zeroing in on a specific value. It's just randomly, different values. Okay, so take a look at this one. Is this one also going to alternate signs or no?
Yes.
It is. Okay, so negative 2 to the power of 1 over 2 is negative 1. Let's start at 0. What's a sub 0? Okay, so a sub 2 is 2. A sub 3 is negative 4. Then 8, negative 16, 32, and 128. Okay, so the question is always, how many do we need? You need at least 5, okay? And then if you still can't figure it out, go for more. So we have a half, a negative 1, a 2, a negative 4, an 8, a negative 16, and then this is where it really starts to show, right? Because you have 32, negative 64, and 128. So do you see how this one too, it's alternating, but that's not the requirement, right? What tells us that this is going to be divergent is, are the values zeroing in on one specific value? No, that's not happening at all. So this is divergent. Yeah, if they were like, starting from like far away and then eventually like coming down to a number. Yeah. So listen, and it doesn't have to like converge to 0 like this first one did. It could all like, oscillate around, let's say y equals 3. So then it would still be convergent. Okay, this one, I'm just going to give it to you. A sub 1 is 0.1. A sub 2 is 0.0067. A sub 3 is 0.4 zeros and a 6. A sub 4 is 0.4 zeros and a 57. Crazy. Okay, so 0.1. So these are all positive, right? 0.0067. So that's like here. 0.0006, and then these are just like down there. So what do you think? Who says convergent? Raise your hand. Who says divergent? Raise your hand. Definitely oh. Yes, it would be lower. Oh, that's 0.06. Sorry. Yes, then it's lower. Then it's much lower. It's like down there somewhere. Yeah. Okay, yeah, down there. So this is definitely convergent. And you can see, right, as the values are, as you're progressing through your series, these are like, reducing to 0. Okay? Now, I keep saying series and I need to, in my mind, they're different things. So this is a sequence. A sequence is literally a list of numbers. Now, imagine you took the list of numbers and instead of the commas, you put pluses. So now you're just adding all of those values. Then it becomes a series. So that's the difference between sequence and series. And I need to like not alternate the two because they're not interchangeable. Okay, a series is the indicated sum of all the terms in a sequence. A finite series is the sum of all the terms in a finite sequence. An infinite series is the sum of all the terms in an infinite sequence. So here, look at the sequence. 1, 3, 5, 7, 9 is a list. And if I just add all those up, then it becomes a series. An infinite one, 1, 3, 5, 7, 9, dot, dot, dot. And then the series has a plus, dot, dot, dot. Okay. Now, suppose you have a list of 1,000 numbers, and or suppose you have an infinite list, right? And you just want to add the first 100, that still becomes a finite list or a finite series. Okay? All right. So we also do that. But it so is. Yeah, you haven't even lived. So the next time you take, we should have done this like before, you know, the trip, so you could have done this on the plane. Well, you know, yeah, it's okay. Missed opportunity. What can I do? I can't. We can't do it all. Huh? Southwest doesn't have TVs, but it's okay. You don't need TVs. No. See, there you go. You could have done this. You could have done this. Yeah. You could have been like, okay, what is the sum of the first this many, even numbers or whatever? Oh, I could have done math. Oh. It's like what is like the cumulative chances of like blah blah blah. Okay. So the sum of the first n terms in a series is called the nth partial sum. So if I have a series of 1,000 numbers and I want the sum of the first 50, that's the 50th partial sum. And it's denoted by S sub n. So for example, S sub 50. To find the nth partial sum, you find all the terms and then you add them all up, pretty much. Okay? Very straightforward. So, find the fifth partial sum of this. Okay, so fifth partial sum means I want S sub 5. That means I want the first number and the second number and the third number and so on. Now, like I said, this first lesson is just a general lesson on sequences and series. And then the next two are, they have patterns, so it'll be a little bit different. So A sub 1 is -2. Is everybody okay with how to find these numbers now? Okay. A sub 2 is 1, then 6, then 13, then 22. And then S sub 5 is literally just adding all these up. Okay, and if I were to give you S sub 220, you would have to find 220 numbers. That was a series, Madeline, of sneezes. Yeah, that was a finite series of sneezes. 457, Yali. For you, 458. It's okay. It's okay. 40, yeah. Yep.
So for the graphs, really, you want to find A0, like for these.
Yeah, for these, just start at 1. Oh, sorry. What am I doing here? These were supposed to be A1, A2, A3, A4. What's A1 here? Oh, you know what? Actually, I'm not going to do it this way. I'm just going to do it like this. S4 is A1 plus A sub 2 plus A sub 3 plus A sub 4. So S sub 4 is 3 plus, it's 3 halves, right? Let's go fractions. Let's go with fractions. Plus 3/4 plus 3/8. Isn't that cute? So this is 45/8 or 5.625. Now, you will have your calculators available for these, right? So if I ask you, give it to me in exact form, you can just convert it to a fraction with your calculator. Yeah, I'm going to give you a calculator because listen, you're not going to, this is silly, like, right? Come on, we're not draconian. We just need to, huh? Oh, you're going to Google that. You're going to Google that. Draconian. Oh my gosh. You all need to Google it. No. Okay. I'm not gonna go into it. But figure out where it came from and who it's named after, that word. No. It's like history.
Oh, no way.
Let's talk about sigma notation. Sigma is one of the Greek letters, just like in the English alphabet, right? There's like A, B, C, D, and then L, M, whatever. One of the letters, like in the Greek alphabet, you have alpha, you have beta, you have delta, you have gamma. One of them is sigma. This is lowercase sigma, and uppercase sigma is that, okay? So that makes like the S sound, okay? And I have a pet peeve, which is when people use like these types of like cool fonts to write things. So for example, there used to be a show called Greek, and Greek, they spelled it as like GR and then two of these and K, right? Well, I could never even watch the show because that is not Greek. Those are two S's. That's like saying GRSSK. And I'm just like, I would like boycott it because it's just silly. It's like Gersisik, right? Like that is just silly. Like if you're going to use this stuff, use it for real. Okay. So, and I have several examples of this. After I teach, I'll show you another one. Okay. So sigma, that letter sigma is used for sum, right? S for sum. Okay. So instead of saying add up the blah, 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 I can write something like this. I have sigma of A sub n from n equals 1 to k. That means add up A sub 1 plus A sub 2 plus A sub 3 plus A sub 4 until the subscript reaches k, until A sub k. You see that? Huh? Yeah, exactly. You have a starting point, okay? So, no, okay. Vocabulary. N is called the index of summation. K is called the upper bound. 1 is called the lower bound. So then when you have an integral, it's just a squished S, the sum, okay? So now, okay. So this says find each sum. So we're adding this up. This is in here an explicit formula for A sub n. So when it says sum up this A sub n from 1 to 4, I want to add up A sub 1 plus A sub 2 plus A sub 3 plus A sub 4. So if I was driving down the street and on a billboard, I just saw this black, right, the stuff printed, I would say to myself, okay, we need to find A1 plus A2 plus A3 plus A4. Okay? So A sub 1, now we're going to plug the 1 into the ends here. So 1 squared plus 1 minus 1. Plus 2 squared minus 2. 3 squared minus 3. 4 squared minus 4. And writing this out like this is actually an important skill that you're gonna like use in calculus as well, all right? Because calculus is literally just adding up things, okay? So here we get 0 plus 2 plus 6 plus 12, 20. Okay, this is like my absolute favorite problem over here, this B, okay? So look, it says add all these up from 1 to infinity. So this is going to be A sub 1 plus A sub 2 plus A sub 3 plus dot, dot, dot. So let's do it. 3, okay, so this is, when I'm going to do A sub 1, right, it's 3 times 1 over 10 to the 1, correct? But can I concisely write that as 3 over 10 to the 1? Are you guys okay with that? So the next one would be 3 over what? 10 to the 2. 3 over 10 cubed. 3 over 10 to the 4. Dot, dot, dot. Again, don't ask me how many you need. You need at least 4 until you see a pattern, okay? So This is going to be 3 over 10, 3 over 100, 3 over 1,000, 3 over 10,000, plus dot, dot, dot. And you're like, okay, well, what about that? Well, let's go to decimals now. This is the first time I'm telling you to write something in decimals. This is 0.3 plus 0.03 plus 0.003 plus 0.0003. And when you add all these up, 0.3 plus 0.03 is 0.33, plus the other one is 0.333, 0.333. Okay? Well, okay, you all know how I feel about the repeating bar, which is I hate it. So, but what is this in fraction? It's 1/3. It's 1/3. So this sum here, this sum is 1/3. How cool is that? Come on, how cool is that? Right? That is actually pretty cool. It just goes to 1/3. Come on, this is so cool. This is like the coolest thing ever, huh? Well, in decimal form, it's 0.3 repeating, but in fraction form, in rational form, it's 1/3. Okay, now, what if I give you this? Okay, 0 plus 2 plus 6 plus 12, and I said, come up with this. Okay, so what if I give you this, and I say, come up with that? So that's what we're going to do now. Well, first we have to figure out a pattern. Okay, now this pattern, here's how we're going to do it. We're not going to relate the numbers to each other. We're going to relate them to their subscripts. So this is the first number, right? So that's n equals 1. Hang on, we are. This is n equals 2. This is n equals 3, 4, 5, 6, 7, 8. Okay? So n equals 1 means negative 2 is the first number. N equals 4 means 1 is the fourth number. In other words, this is a sub 1, a sub 2, a sub 3, and so on. Now, we have to come up with a pattern, but not relating the numbers to each other horizontally, but relating it to each of the n's. So for example, what's something you can do to the value of n to get that number? So what could you do to 1 to get negative 2? And then the same thing you would do to this to get that, and to this to that. It looks like it's minus 3, right? 1 minus 3, 2 minus 3, 3 minus, okay? So that means the formula for a sub n is n minus 3. So you're taking the value of n minus 3. So now, when you write your sigma, it says the lower bound is given. So this is n equals 1. And then what's the highest number you're going to? This goes from the first number to the 8th number. So the last number is k. So it goes up to 8. And then in here you put n minus 3. Put it in parentheses. Okay? All right.